Hello class, this is Professor Chris Bjorkrum. This is the first video of the semester for Computational Practice. I'm going to be roughly introducing the Revit interface and then beginning to introduce the conceptual massing, which we're going to be using to, in this tutorial, lay out different floor plates through a sort of tower form or shape. And use that as a method for just beginning to discuss how it is that we can actually frame conceptual ideas much in the same way as you might in Rhino, and trying our best to make a transition between the two. Okay, so when you first open up Revit, it has this splash screen which allows you to open a sample architectural project or advanced sample project. You should go poke around in some of those and actually take a look at what's possible and what all goes into a single file. The advanced project actually has ductwork and all sorts of mechanical parts inside of it, and you can get a sense of just how much detail can go into a model inside of Revit. You'll see that there are two different types of models that you can actually start with inside of Revit. One is a project. A project, of course, is the building model, can have all of the detail that you might imagine that would go into any sort of building design. Families is, you can see here, between projects and families is where we can do a lot more customization. And inside of families is where we define all of the parameters and relationships that define, say, a custom window or door or wall type, or potentially using a different kind of curtain wall system, any sort of custom geometry that you might want to play around with. You're going to start to develop inside as a family, give it relationships or parameters, and then instantiate those pieces into a project file, applying it to a surface or other geometry. As we get further along in the semester, of course, we'll be doing a lot more of that. I should say up front, there are 5 different ways to do everything inside of Revit, and just because I show you one way here in the video does not necessarily constitute the best way. And so as you find smarter and faster ways to actually do things, I do hope that you'll share them with me, you'll share them with one another, and that may even be the case today as you go through this tutorial. So you'll see here the conceptual mass is actually a family type that's down here. And I'm going to open that up real quick, and you'll see that this actually opens up a template file called Mass, Conceptual Mass, and it's going to open up the mass, the Conceptual Mass kind of interface here inside of Revit. It's basically a slimmed down version of the entire interface that you might find once we go into the project setup. There are 2 ways to do conceptual masses. Basically, this is a very sort of simple kind of sketch mode that allows you to draw things, create relationships, create parameters between different pieces of geometry, much in the same way that you might with Grasshopper, say using an offset command in Grasshopper to say that you want to control the height difference between things. We'll start getting to that on Friday inside the labs and over the weekend in the next video tutorial that you'll start after the lab on Friday. So inside of this interface, if anybody's ever used Vasari, you'll notice that this looks very similar. Vasari is a simulation tool that you'll be learning in BSI. Those of you that are in 5th year are going to be learning it very shortly. Those of you in 4th year, you'll wait a year and start picking some of that up, although we may touch on it a little bit in this class. So inside the interface here, it's a very slimmed down version, as I was saying, where we can create reference planes and then pieces of geometry, and then start turning those pieces of geometry into surfaces and solids and building masses. And you're welcome to kind of poke around in here. I open this only to sort of show you that, again, there are multiple ways of doing everything. The conceptual mass can be done here as an individual file that's saved and then loaded into a project file. Alternatively, it can actually be done as a part of the project file, and that's actually how we're going to do it today. So I'm going to come back up here to the small r and create a new project This can also be done at the top. I'm using the architectural template, although I don't know that it really matters a whole lot. Okay, so here's the main interface for Revit. And you can see that across the top are all of our different kind of create tabs. And there are two primary windows that we'll use. One called Properties and another one called Project Browser. Project Browser, for some of you, may be sort of nested down here in the bottom corner. I prefer to kind of nest one on each side of the modeling window so that I can more fluidly kind of move back and forth between them. In essence, the properties are going to be where you can define the characteristics of anything that you're working with. And in the project browser is where you're going to be able to navigate around between different drawings. Every time you click on one of the pieces inside of the project browser, it's going to open an entirely new window. So for instance, if I click on the east elevation here, I'm going to see the two levels that are in here by default, level 1 and level 2, level 1 at 0 and level 2 at 10 foot. You can see those two things are here. If I minimize this window, you'll see that I've actually got that original conceptual mass still back there, and here's floor 1, and here's that minimized elevation. All of those different pieces open as different windows. So as you're clicking on these, you're simply opening different windows to view each of the different parts of a file. You'll notice by default there's no 3D view actually open in here. If you hit the View tab and hit 3D View, that'll go ahead and create that. Now you're moving around in 3D, although we need to draw something in order to really be able to see it. So back in level 1, you can use the middle mouse button to pan around inside of here, and you can scroll. You're going to want a 3-button mouse if you don't have one. You definitely don't want to be doing this with a trackpad all semester. So you'll be able to actually use the middle mouse button by pushing it to pan back and forth. I'm just in 2D here, so I'm only zooming and panning. And I'll show you how to get around in 3D here once we create something. So I'm just going to quickly kind of draw a floor. So when I click the Floor tab underneath the Architecture tab, it's going to immediately take me to this Modify piece, where now I can draw and I see all of the conventional tools that I'm used to actually working with. Move, copy, rotate, trim, extend, mirror, offset, align, all of these different things. You can also see here there's always this mode, and you'll want to pay attention to this inside of any sketch. The checkbox and the X are always going to confirm that you're done drawing. And so when you're drawing in here, you're going to have to check that green box whenever you want to actually confirm that you're done drawing whatever it is you're drawing. In this case, I'm drawing a floor. I'm just going to quickly draw a kind of rectangular floor and hit that checkbox. You can see that creates my geometry. I simply see it as a rectangle here. If I go into 3D view, though, I should be able to zoom out, and now I can see the thickness of this floor as it was defined just as a generic 12-inch floor you can see over here in Properties. So now that I'm in 3D, you'll see that I can hold the Shift key and the middle mouse button down, Shift key and middle mouse button down to actually swirl around, and again, middle mouse button to pan. You can also use this navigator by clicking on different parts of it. It will throw you into different views of whatever it is you're looking at. So if you want to snap to the top view, you can kind of click on this and you can spin using the ring around the box. I prefer just to kind of navigate much in the way I do with Rhino. I can select this and actually always go back and hit Edit Boundary. You'll notice that the X and the checkbox open back up. Say if I want to take the corner off of this, I can draw a line, and then I'll use the Trim Extend to Corners to actually clean this up. Just by clicking the stuff that I want to keep, you'll see that that kind of cleans it. Select this guy and delete, and then hit the checkbox to finish the geometry of that floor plate. First, I want to just talk about how the interface is sort of set up now that we have some geometry to see here. So here under Architecture is where you're going to draw all of your conventional architectural elements: walls, doors, windows, roof, ceiling, floor, curtain grid, mullions, ramps, stairs, railings. All of this stuff is going to be found here under the Architecture tab. Under Structure is where you see more specific kinds of objects that you can use that will have properties associated with them that can be analyzed using some of the built-in tools in Revit to sort of define how the structure is actually functioning in the building. So these pieces of geometry aren't just geometry inside of a model, but instead are actually elements that have information associated with them in terms of their performance. You can go to systems here and you're going to see all the kind of mechanical systems, from plumbing fixtures to sprinklers, ductwork. We are probably not going to get to very much of this during computational practice. We may get to some of it in the fifth year studios this year. In insert, this is where you can create linkages between images, so you can manage images as underlays, and where you can link other Revit files or CAD files to your Revit model. And we're going to be doing this in the video tutorial over the weekend. Annotate. So here in Annotate, you can actually come in, and this is where you can define dimensions and tags to define the relationships of different objects, so you can navigate through the model. So say a room tag, which would define the room name and potentially the square footage and certainly what its program is. Analyze, here is where some of those built-in tools are for analyzing the model. Again, this requires you to be aware of exactly how it is that what you're using to model and how you're modeling it. Massing and site, this is where we're going to be back to in a moment. As I said, you can do a conceptual mass as a separate file, as a family type, but you can also do it here in the project, in a project, and this is what we're going to be doing momentarily. We'll be coming back to this. And again, conceptual masses are just about sort of framing the exterior shapes and geometries, sort of like what you would do in SketchUp or Rhino in the initial phase of a project. Collaborate, we won't be doing very much of in computational practice using these tools, but in the fifth year studios we will be using this to activate what are called work sets, which are pieces of a model that can be signed out to people from a server. So you store your file on a server. Revit automatically knows that it can deliver different work sets or different parts of the model to different users, and then compile them back together at the end of the day. So those of you that are working in pairs this year in studio and fifth year, you'll use this to actually help yourselves to work collaboratively during studio on the same model. View is where we can do renderings and where we can change the visibility graphics, which is something you'll use all the time. You can hit the letter VG for that. This is where you can create new 3D views, new plan views. All of these things will appear here in the project browser as you create them. Manage. This is where you can associate materials and different things. There's not a whole lot we'll be doing here. Addins is where you're going to see different plugins. This is where Dynamo is actually located. You hit this big Dynamo button. Revit right now has 2 different installs that are actually running, and you can click on whether you want to run the older one or a newer one before you actually get going. Flow Design is another plugin. And then here at the end again is the Modify tab, where you're going to be most of the time in terms of defining the actual geometry. Okay, so back here under View, what we want to do is actually create some, excuse me, just going to make sure this is, okay, so what we're going to do is here is actually create some new floor plates. I'm going to delete that floor that I drew, and starting here with level 2, I'm going to select level 2. Sorry about that. Okay, so I've got View 2 selected here, and I'm going to hit the Array button under the Modify Levels tab. And you can see here in this green strip, you're going to want to pay attention to this green strip whenever it pops up. And what this is doing is asking how many copies I want to make. So I'm going to put in 20 copies of this, this floor. And I can drag up to define the height, and I'm gonna, you can see it's snapping to 6-inch increments. I'm gonna put it at 12 feet. And you can see here it allows me to adjust to define exactly how many copies. So if I want, I can type in 18 in order to define. And you can see that this has created all of these new levels. It didn't actually create any floor plans to go with them. This is just taking each of the levels and sort of associating them with different pieces of the geometry. I can at any time then go to View and actually go to Plan Views and create plan views of those other levels. So here under View and Plan Views, I can select Floor Plans and Shift Select, and it will go through and create all of the views from level 1 to 19 through the model. You can see this can get a little unruly as your building gets bigger. So here on back in level 1, we're going to go ahead and start creating a mass. And so here under the Massing tab, I want to create an in-place mass. We'll just call it Mass 1. And I'm going to get this same set of tools where I can define different pieces of geometry. And I'm just going to kind of click through and make a sort of funky floor plate here, closing it out. And then I'm going to jump up to level 19. And here on level 19, if I select the level itself, I can actually come in here, and you'll see here under Underlay, I can turn this so that I can see level 1, and that'll allow me to actually see the geometry of the floor plate that I drew down on level 1, so I can reference it. When I get that little square tab, that means it's actually linking the two. Once I get both of those drawn, I'm going to go into the 3D view. Not sure where my... There we go. I can see my two floor plates here, and I'm going to select them both. Just going to draw boxes so that they both all turn blue. And then I'm going to hit Create Form. And you can see that this is actually going to create a kind of mass between the two pieces of geometry. And then I can hit the checkbox again to sort of finish that mass up and make it into the piece of geometry that I want. So back here in the massing tab, or excuse me, under the Modify Mass tab, once I've got this selected, you can manipulate this geometry actually by sort of pulling on different parts of it and shifting things around. Each face then is a piece that you can maneuver, although obviously some of them are sort of linked to one another in pretty meaningful ways. Okay, so then we can create floors between each of these different plates by hitting this Mass Floor button inside of the Modify tab when I've got this selected. And you have to go through and check the boxes for each one that you want it to make. Okay, and you can see how it's going to slice up my model, and you can see because I pulled on the top of this tower, the top of the conceptual mass goes beyond the top of level 19. So it actually just drew it wherever the height of level 19 was as I go through each of the floor plates. But I'm kind of okay with that. So each of these, obviously, you can see doesn't really have a thickness yet. Once I've got these in place, then what I can do is come back to the Architecture tab. Excuse me. Okay, so in order to get the floors attached to each of these actual architectural elements attached to each of these floor plates, I want to select the conceptual mass and go to Architecture here, and then hit the little arrow next to the Floor tab so that I can see different options for the floor. And I want to make these floor by face, and it's going to make me select them all again. And then I can hit Create Floor, and it's going to go through and actually give me those thicknesses. Again, just using when I select them, that's the slab there. It's just giving me a 12-inch generic floor plate, and we'll go back and kind of talk about how those things work and can be manipulated later on. But what I can do now is I can pull on this geometry and actually manipulate those floor plates. But what you can see is that when I pull the conceptual mass back, it actually doesn't necessarily change the way in which the floor plates work, or the floor plates that are associated with it. What I can do in order to get those linked with one another is to select everything. And you can use this filter button to actually tell it what kinds of things you want. So when you draw a box around a bunch of things, you're having difficulty selecting them. I'm just going to select the floors themselves, hit OK, and then can say Update to Face. I'm going to get a little bit of an error because that geometry isn't quite flush anymore. Let's try that again. I probably sort of tied a knot in the conceptual mass. So there we go. Let's try this one. So again, I'll select all of the objects, filter, just want the floors, and then hit Update to Face. And now we've got those floors updating to the conceptual mass geometry that we're working with. You're going to want to make sure as you're working through these things, basically in the lab, I want you to go through, or before the lab, I want you to go through, save yourself a little tower geometry with, say, 20 floors on it, and kind of, just play around in the interface. Start to familiarize yourself with how to get around and how things work inside of here. So to save any file, it's just as you might expect. You can hit save. I'm just going to save this to the desktop. Once you save something, that'll enable the autosave, which will continue to update over and over again. But initially, you'll want to make sure and save the file right away, because if you don't save it, then it's not actually doing any autosaving. So I'll call this Lab 1 and put my name in it. Please follow this same procedure for each file that you submit. You'll want to say which lab it's for, which lab assignment it's for, and please be sure to include your last name in the file name before you save it. So I'm going to hit save. So up on the Moodle, you'll find that there's an assignment available for you to submit these files. Most of these labs are just going to be checked for completion, but they will be due before the lab actually begins. So for instance, this video is for the Friday lab. And you'll need to make sure that you submit that before your lab begins at either 9 or 10 a.m. All right, I will see you guys on Friday.